Welcome to this video where hopefully students will get the help that they need in either learning or reviewing the concept in Chapter 1, Section C on sets and Venn diagrams. Up until this point in the Math 140 class, we've been representing information by graphs and charts and frequency tables. We've looked at statistics associated with them. And now we're going to look at what people arguably sometimes will call a more simplistic representation of information. And this is something called a set. A set is nothing more than a collection of items. We like to use the word at CCC, a lot of things. It could be a set of numbers. It could be words. It could be pictures. It could be diagrams, just as long as it's a collection of items that we can express. We can do this in one of three fashions. The key phrase or the key notation we always have to remember is if we use English words, we need to always put the set in braces. For example, if I were to go in and let's say I were going to write the English phrase days of the week, that would be an English phrase. For that to be considered a set in mathematics, I've got to use these braces that go around it. So I would surround it by braces like that, and that would be a rule stating a description of what this set is. If I wanted to list those elements or those items, I could put them in braces, and I would start with Monday, Tuesday, separating by commas, and go all the way to Sunday. And you could list all 7 of them. If it's an established pattern that most of the world understands, you could even put 3 little dots called an ellipsis to represent this. Now, you would not say Monday, ... Sunday. You need to get the list started so that the average person could understand the pattern. By the same token, I would not do 2 ... 10 because nobody knows whether you mean 2, 3, 4, 5, 6, 7, 8, 9, 10 or 2, 4, 6, 8, 10. They don't know if you mean all the numbers or just the even values. But if you start the pattern, it would at least give an idea of what's being meant right there. So you want to be careful when you're doing the list. If you're using these dots inside the braces, be careful that the average person understands it. The third method is by using a special kind of picture called the Venn diagram. The Venn diagram, named after a mathematician named Venn, deals with circles and sometimes rectangles involved with it. And I'll show you several examples of this, and specifically the Venn diagram in just a minute. If I go down here, I've got 7 examples already listed for you, very generically. Number 1, people whose names begin with the letter A. Now that doesn't mean necessarily anybody on earth, but it's just a description of a list. So it could be Andy, Arthur, Adam, Abigail, Alicia, Atrina, whatever. I saw an Atrina in the supermarket today, and that's the reason the name came to mind. I could use an example again. They're in braces. I could just use a list rather than the rule rather than I had earlier. Number 2 is a list of very special numbers that I'll describe in class called the Fibonacci Sequence, but they're listed right there: 1, 1, 2, 3, 5, etc. Number 3, I've got a rule, the set of odd integers. Those are your whole numbers in this case, between 2 and 14. The odd ones would be, if I listed them, 3, 5, 7, 9, 11, 13. Number 4, over here, I have established the even integers starting with 2 and ending with 100. Instead of writing all of them, I put those little 3 dots. I did 2, 4, 6 to get the list started. Numbers 5, 6, and 7 are the ones that I refer to by this term Venn diagram. Sometimes you'll see them as circles that are separated from each other. Sometimes the circles will overlap, and sometimes they'll have one circle contained inside the other. For example, in number 5 right here, I've got 2 circles, a Venn diagram. I've got even integers, and that circle is completely contained inside the big circle of integers, because what I'm saying here is that everything inside the red circle is also contained inside the blue circle. In other words, every even integer is also an integer. I'm talking about all numbers, all counting numbers, and positive and negative, and all even ones. So I may do that. Something that might be easier for you to see maybe would be, if you talk about English class, I could put verbs right here, and if I surround that circle by words, all verbs are words, so that's why I have the one circle inside the other. Contrast that with number 6, where I have males and females, but if I have a diagram in the form of a Venn diagram, the male and female circles would not overlap, because in a normal situation, we don't have an overlapping where I have all males are not females and all females are not males. They're completely separate or disjoint groups of items. If I had negative numbers and positive numbers, I would not put them in the same circle because a number cannot be negative and positive at the same time. Number 7 can get a little trickier, but not hard if you understand it. With number 7 right here, I've got, if you can't read this, I've got plumbers and painters. And what I have here, I have two circles that overlap one another. Because I could have a person that is only a plumber, but not a painter, so they're in this yellow area, and I didn't color everything. I could have a person that's a painter only, but not a plumber. I could have a person that has both talents. So where the circles overlap, I have people who are both plumbers and painters. And then completely outside all the circles is I have people like me who are neither a plumber nor a painter. So I've got one trait, plumber, another trait, painter, another trait, both at the same time, a person that plumbs and paints, I'll use that verb, I'll make it up, and people who do neither one. Another example, and the Venns are the ones usually that are the toughest to understand. Here goes. Here's an example right here. I'll try to get this up here. This is a diagram. It's a little nicer looking, and I hope you can read the words here. I've got nurses and parents overlapping. I could have a nurse that doesn't have children, so that'd be in this area. A parent that's not a nurse, so in that area. I could have a nurse who is also a mother or father of some children, so there's an overlap right there. And I have people completely on the outside of both circles who are neither nurses nor parents, like me. Now, if I were to put some numbers in there, I want you to understand how this works. If I add all those numbers together, in this case, I've got 28 people, 6, and you may not be able to see these numbers, so I'll make them a little bit darker, 6, 10, 5, 7. In this particular diagram, I've got 28 people total. I've got 6 people who are neither nurses nor parents. I have 10 people who are nurses only, 5 people who are both nurses and parents, and 7 people who are parents only. If I add those numbers together, I get 28. In the entire diagram, I have 15 people who are nurses because I've got to include both these groups, both the nurses only and the parent nurses. I have 15 nurses altogether. I have 12 people who are parents. I didn't say parents only. 12 people who are parents because I got the 7 parents there and the 5 extra parents who are also nurses. I've got 6 people in the diagram, as I said earlier, who are neither nurses nor parents, and they're the ones outside the circles. Basically, you need to understand the concept of this diagram in order to successfully do the exercises. The exercises in your book primarily, I think I'm right, forgive me if I'm wrong on this, I think the exercises in your book that you'll work on with sets and Venn diagrams are on pages 46 and 47. I hope this video will help out, but if you need additional assistance, get with a fellow student or with a tutor or contact me.